Hi guys, welcome back to another tutorial on the UI system. In this one we're going to look at multi-selection like you'd see in an RTS game. So we'll start off by creating a plane and we'll move our camera so that our camera is looking down at the plane. We're going to set up a few things on the camera. So I'll position it just about 10 away from the scene. I'll make it an orthographic camera. It just makes the math easier than a perspective camera. Have a look, that looks nice and set up. Right. I'm also going to add a physics raycaster to the camera. Physics raycaster is quite important for using the event system. We'll go ahead and add an event system. If you're not familiar with an event system is for processing input that comes through the UI. Right, now we'll go ahead and create some character objects that we can select. I'm just going to use cubes. And we'll scatter some around the scene. I'll make it a prefab too, that way any adjustments we make will apply to all of the cubes. Alright, that should probably be about enough. Next thing we need to do is add a script. I'm going to call this mySelectable, and this script is just going to take care of selection on those cubes. So let's go across to Visual Studio. We'll add in a couple of using statements. We're going to be using system.collections.generic. Almost always end up using this. And we're going to be using Unity Engine .event systems. So that's the one we use to indicate which events we're going to intercept. So now we'll go ahead and define what events we want. We want iSelectHandler, we want iPointerClickHandler, and we actually want iDeselectHandler as well. If you're going to implement iSelectHandler, it's normally a good idea to implement a deselect as well. So we'll go ahead and put those interfaces in. Okay, now we have all our interfaces, so that will intercept the events we need. We'll get rid of start and update because we're not going to use start and update for our purposes. Alright, we'll go ahead and create a public field, and this is going to be a hash set. If you don't know what a hash set is, check out my other video on collections. But this is just going to be a hash set of mySelectables, and it's going to hold all of the selectables. Note that we've made this static. That means there'll only be one variable for all of our mySelectables. We're also going to make another static hash set which of mySelectables, which will contain the ones that are currently selected. That way we can do useful things like get all of the current selected ones and do something with them. Right. To make all selectables work, we need to add each selectable in awake. So we're just going to go awake and we're going to mySelectables.add. Alright, we're also going to want a reference to our render. This is not needed for the selection, but we're just going to use it to indicate something, which objects are selected and which ones aren't. So I'll go ahead and add to awake. My renderer is getComponentRenderer. That means we've got a renderer reference there. Alright, let's go through and look at our interfaces. I'll just rearrange that so that it's a little more neater. We will need a couple more variables. We're going to expose these to the inspector, so we'll use serialized field. Again, these are material ones. They're not strictly needed for a selection. I'm just going to change the material to indicate whether an object is selected or not. So we'll have an unselected material and we'll have a selected material as well. In our onPointerClick method, all we're going to do is call onSelect. So basically that says when we click on this, select it. And you'll know that it's just passing through the same event data that it gets. Now in our onSelect, we're going to do a couple of things. First, we're going to deselect everything. This will mean we can only select one object. So whenever we select a new object, it'll remove all of them. And then we're going to go to currently selected, and we're going to add this. So we'll add this selectable to the currently selected. Let's go ahead and define that deselect all. We're going to make it public and static. Static because it's meant to affect the entire class. It's not just meant to affect one instance. And because we're going to be using event data in our onDeselect, we'll just pass in the event data there. Alright, so now we'll just set up a simple for each loop. So for each mySelectable in the currently selected, we're then going to call onDeselect. We'll just use selectable.onDeselect, and we'll pass in the event data. Once we've done that, we need to empty the currently selected list, and we'll just use currently selected.clear. You could call a new list, but that would result in garbage collection. Right, now on our onSelect, we're going to change our render material to the selected material, and then our deselect will do exactly the same thing. We'll change our rendered material to our unselected material. Alright, we'll save that. We'll head back to Unity and we'll see what happens. Before we run a playtest, let's go ahead and create these materials. So I'm just going to create two new materials. One that's going to be called unselected, and that one is going to be blue. And we'll create another material and call it selected, and we'll make that one red. That's nice and easy. Red if it's selected, blue if it's not. We'll drag those in to the mySelectable, and we'll give them the unselected material to start with. There we go. Now you can see the cubes. You can see when I click on one, it selects and it automatically deselects all of the others. Alright, so that's single selection. But let's go ahead and make that multi-selection now. So the simplest way to do multi-selection is just to not deselect things. So we'll wrap our deselect all call in an input.getKey, and we'll check for the control key. That's a common key to hold for multiple selection. There's two control keys, so we need to check for left control and right control. So basically, if neither the left control or the right control is down, it will deselect it all. But if the user's chosen either of the control keys, they can now select more than one. Alright, let's go ahead and give that a test. You can see I'll hit play, and when I'm clicking them, they still click as normal, but if I hold down control, it selects multiple. If I remove control, it goes back to deselecting them all. Alright, now we're going to implement our drag selection. So we'll start off by creating a canvas. We'll make it camera space. Camera space just makes the math a little bit easier. We want it to be closest to our camera, so we're going to make the plane distance 1. We'll then create an image on that canvas, and this image is going to pick up our drag. So we'll just call it the drag handler. Now we're going to stretch this image out so it covers the entire screen, which will make it draggable anywhere. And then we're going to reduce the alpha to 0. So we have this image there that's always clickable, but it has no, it can't be seen. Right, we're going to go ahead and create a drag box. So a drag box is, we're going to use 9 slicing. So it's a simple 3x3 texture. We'll use a nice screen color around the outside, and then we'll just make the center pixel transparent. Unity's 9 slicing will actually stretch that border out and stretch that transparent area. There's probably fancier ways to do this, but I'm not a UI artist, I just know how to build the things. So we'll save that in our assets folder. Right, we need to set up a couple of things. Because we're using it as a UI, we need to make it a sprite. So we'll go ahead and make it a sprite. And we also want to set up the 9 slicing, so let's go ahead and set that up. To set up the 9 slice on this is quite simple. We just drag the green border in. So the blue border shows the edge of the sprite, and the green border shows the edge of the 9 slice. We'll hit apply. And we want to change the filter mode to point, and that will get rid of the sort of blurring that we have. So let's go ahead and create an image. We'll drag that selection box in, and you can see the 9 slicing has stretched it out, and we'll give it a name. We'll call it selection box. So that's the setup for our drag. We're also going to make that inactive. We're only going to turn it on when the user's actually dragging. Right, let's go back to scripting. We'll go to our drag handler object, and we'll make a drag selection handler script. And let's edit that script. So same thing, first we're going to set up a couple of namespaces. We'll use Unity engine.ui because we're going to need references to the UI. We'll also need references to the event system for the events we're going to be detecting. So we'll go ahead and we'll set those events that we want to intercept up first. So we want a begin drag handler, we want drag handler, and we want end drag handler. So a drag has 4 components. The other component is the drop. We're actually not going to use a drop in this. We're just going to use begin drag, drag, and end drag. We'll also get rid of start and awake because we're not going to be using those methods. Right, we'll set up a couple of inspector variables that we're going to need. So the main one we'll need is a image reference to the selection box. We'll also need a couple of internal variables. So we're going to have a vector2 for the start position. That's where we start the drag. And then we're going to have a rect. So a rect is just a rectangle, and we'll call it selection rect. And that will just define whereabouts our box should be. Right, so in the begin drag, the first thing we're going to do is set the game object of selection box image active. And then we're going to set the start position to event data.position. That's basically the position of the mouse in screen space. And we'll create a new selection rect. Selection rects are a struct, so we don't have to worry too much about garbage with them. Right, and now on drag, we have to do a little bit of math here to determine the boundaries of our rects, because unfortunately we have to figure out if the X corner is lower than the start position or higher than the start position. So if you look, if our X is less than the start position, we're going to set the X min to the event data position, and we're going to set the max to the start position. Otherwise, so this will be if our mouse is greater than the start position, and we're just going to swap those round. So the min will be the start position.x, and the max will be the event data position. Remember, event data position is the same as the mouse position. We'll then copy and paste that, and we'll do the same thing for our Y. Literally just changing all of that, copy and paste that, and changing all of that to Y's. Right, so now we've set up a rect which contains the area that we are selecting. So the next thing we need to do is assign those coordinates to the rect transform of our selection box. So we're going to go selection box image dot rect transform, and we're going to set the offset min, and we're going to select that to the selection box rect min. And we're going to do the same thing with the offset max. Unfortunately, we can't just assign a rect directly to the rect transform, but this is almost the same. Alright, let's sort out what happens when we finish the drag. So what we're going to do is we're going to turn the image off, because we no longer need that box showing on the screen. So we'll just go selection box image.gameObject.setActiveBox. Now we're going to go through and check each selectable in the mySelectables.AllSelectables list. If you remember, that was a hash set that contained every selectable in the game. A hash set will work well for our purposes, but if you were doing this with hundreds or thousands of units, you'd want to implement a smarter data structure. So for each selectable, we're just going to see if the selection rect contains it. Now we do have to convert it from a camera point to a screen point, from a world's point to a screen point, which we'll just do with this method here. And then we're just going to call onSelect on the selectable. It's as straightforward as that. Now there's a couple of other changes we need to make. In the mySelectable script, you note we've got the deselect call in onSelect. Let's move it out of there and put it into the onPointer click. And then we don't now have a deselect call in the drag handler. So we'll go ahead and create one on begin drag. We'll just call deselect all. We'll pass in some event data for it. And we'll go ahead and we'll wrap that in the same if for the control keys now. That way, if we hold down control and we already have some units selected, it'll just go straight ahead and carry on. Right, back in Unity, we need to grab the selection box from our hierarchy in, and we're also going to set the anchor on that selection box to the bottom left. That's important to make the math work. Right, now you can see we've got a box that we drag and it will select things. I hold down Control, it will select multiple things. Right, one thing we have done, we've introduced a bug. Now just clicking on them no longer selects it. And that's because our drag selection handler is consuming all of the events. So we need to go ahead and create a way to bubble the iPointerClick event through. I'm going to show you a dirty way to do this. If there's interest on a better way to do it, let me know in the comments below and I'll make a separate video on event bubbling. So what we're going to do is we're going to implement the onPointerClick interface. Now in here, we're going to create a list of raycast results. That's going to be a new list. It's in red because I think I need another using statement. Yep, I don't have collections system.collections.generic. So we'll go ahead and add that now. There we go. Now it's happy. And we're going to fill that list from the event system with raycast all. Our basic strategy here is we're going to create a fake raycast through the screen from the event system, and then we're going to get all of the results on that. We're going to search through those results till we find our pointer click, and then we're going to look for the one that would be just behind it. It's really a shame Unity doesn't implement this automatically for us. So we're going to create a float, which is my distance, which will start off at 0. And then we're just going to scroll through all of the raycast results with a for each. On each raycast result, so the first thing we're looking for is to see what distance our result is from the screen. So we're just going to say if the result.gameObject is equal to our gameObject, then we're just going to grab the distance and populate it into that myDistance variable, and that's just from result.distance. And then we're going to break. We don't need to continue looping once we've found our object. Right, we're now going to create a gameObject variable for the next object. So this is the object that we are looking for. We're going to start it off as null. And we're going to set up another float for the maximum distance. So basically we're going to search through that same list of raycast results again, and we're going to look for a float for a object that is between the distance our object is away from the event system and the maximum distance that we've found. And each time we find one, we'll bring the search closer and closer so that we'll only find the object, we will find the object closest to us. So we're going to check if the result distance is greater than my distance, so it needs to be behind this, but it needs to be closer than any other object we've found, which is our max distance. If it is, we're going to make that the new next object. And we're going to update our max distance to the distance of that result. When we get to the end of that loop, if there is a game object behind us, then we've found it. So if there is an object, we're going to call execute events. So execute events is a helper class, and we're going to call execute events.execute. We're going to pass in the interface we're using, which is the iPointer click handler. We're going to pass in the game object. We're going to pass in the event data that we got from the click. So as far as the object receiving this can tell, it's going to be identical to as if it had got a regular click from the event system. And then we're going to do this weird lambda structure thing, but basically X is the same as next object, Y is the same as event data. So we're going to say on the object, call onPointer click, and pass in the event data. Now the event data is looking for a pointer event data, so we've got to cast it to a pointer event data. Looks a little bit weird. You can just go ahead and memorize that sequence. Once you get used to lambda functions, they're quite useful, but they do look a bit weird. So all that's done is just grab the onClick event and bubbled it through. So now we'll give that a try. We'll hit play. You can see each one we click on is now working. Our multi-selection is now working. Our multi-multi selection is working. And it's all fine. I hope you have enjoyed this video. If you have enjoyed this video, please like it or comment on it. Let me know what else you want to see. Share it on all of your social media. That really helps. And if you've really liked this video and would like to see more, please support me on Patreon. There's a link in the description of this video, and there should be a link on screen. Thank you very much.